Okay, so the last thing that we're going to be looking at is looking at finding the area of triangles that are non-right triangles. So we're going to first start with side angle side triangles. So we're going to use K here for area instead of A, because we do use capital A for a lot of things, especially for angles and things like that. So we just want to make sure we're not getting confused. So we're looking at finding the area of a triangle being half the whole base. So if we look at this triangle down here, this whole thing is your base, and then the height of the triangle. So from the peak all the way down, forming a right angle here. So what we're looking at is figuring out how we can do this if we don't have h explicit to us. So B is the base, H is the height, and K is going to be the area. We usually don't have the information for height. And so if we have information about two of our sides and then the included angle, we can use this formula right here, that the area of the triangle is equal to half AB sine C. And the reason is because if I look at from this angle, the sine of C would be H over A. So A times the sine of C would be H. And so if I think about how I could use that in my formula for half base times height, my height would be A sine of C. And so if I rearrange that, I'm going to get this formula that I highlighted over here. And the same thing is true. We have these other formulas as well. They're all just depending on the information you have. So what angle you have information about, what sides you have information about, these are going to be your area formulas. And so we're going to use them to help us. So, for example, I want to find the area of a triangle that has this information. And so the best way to do it is just like before, always set up your angle, whatever angle is given, in the bottom left-hand corner. So that's going to be 30 degrees. And then we want A and B on either side of it. So we'll just say, I don't know, this is 8 and this is 6, so this must be B and A. So when I look at this, I think about, if I don't necessarily know right offhand, I know I can do 1/2 base times height. And so I want to figure out how I can express the height in terms of what I have. So here, my height would be found doing the sine of 30 degrees would be equal to h over 8. And so that would give me 8 sine of 30 would equal h. And so that's what I'm going to substitute in right here. Now base here is still b, right? It's little b, because this would be little b, this would be a. So when I find my area, I can do half times the base, which is 6, times the height, which is 8 sine of 30 degrees. And so then what I can do is I can start to simplify these. These are all being multiplied. So that would be 24 sine of 30. And I actually know what sine of 30 is. I don't need a calculator for that. I know using my unit circle that sine of 30 is a half. And so K must be 12 units squared. And so that would be my area. And then, of course, you could use just the traditional formula if you didn't know all of that. That K would be equal to 1/2 AB sine of C. And so that's another option to use it as well. Now, if I have no information about any angles whatsoever, and I only have side, 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 so 3 sides, then I have this formula here that I'm going to use. And so it's a really interesting formula. So when I think about what this means, I have an S, an S, an S, and an S. And S stands for this whole formula here. It's called the semi-perimeter, and it's half of the perimeter, really. So it's half of adding up all the sides. And then A, B, and C are all going to be sides. So let's see how we can use this. So I want to find the area of a triangle whose sides are 4, 5, and 7. So let's just kind of remind ourselves of that formula above. So you can scroll up and see it, or over time you'll have it kind of in the back of your mind. And we know that S is equal to half of the sum of A, B, and C. So S is our semi-perimeter, and so we need that for this formula. And then we also have A, and I'm just going to arbitrarily decide what these are. So as long as each side is a different value, it doesn't matter which is A, B, or C, because we're not necessarily dealing with a right triangle here. So if I call this A, B, C, we would have 4, 5, and 7. So first I'm going to calculate S. So S is half of the sum of 4, 5, and 7. And so when I add that together, I get half of 16, which is 8. So S is 8. So when I substitute this in here, I'm just going to use 8. So K is equal to the square root of 8 times 8 minus A, so that would be 8 minus 4, times 8 minus 5, times 8 minus 7. So K would be equal to 8 times 4 times 3, not 2, and times 1. And so I find out that when I multiply all these together, I get 32 times 3 times 1, that's 96. And so if I break down, so remember it's how to break down a square root. You break it down and look at what we get here. So we have 3 times 32. This would be 2 times 16. This is a perfect square, so I can pull it out. And then what's left is the multiplication of those two things, which would be 6. And so that would be units squared. So when it comes to finding the area of these triangles, depending on the information you're given, you're either going to be given enough information to use the half AB sine C, or the half base times height, or you'll have enough information with all three sides to be able to find it out using this formula here. And that's it.